Imagine a spacecraft flying directly into the atmosphere of the sun. It sounds like something from a science fiction movie, but this is exactly what NASA accomplished with the Parker Solar Probe. For centuries, humanity has studied the sun from a safe distance, observing it through telescopes and satellites. Yet despite being the closest star to Earth, many of its biggest mysteries remained unsolved. The sun is a giant sphere of superheated plasma with temperatures reaching millions of degrees. It constantly releases streams of charged particles that race across the solar system. Scientists knew that getting close enough to study these processes directly would be incredibly difficult. The heat alone would destroy most spacecraft long before they reached their target. But NASA decided to attempt what many considered impossible. They built a spacecraft capable of surviving the most extreme environment ever explored by humans. Its mission was simple in concept, but revolutionary in execution. Travel closer to the sun than any spacecraft in history and uncover the secrets hidden within its atmosphere. What Parker's solar probe discovered would challenge existing theories, reveal strange phenomena never seen before, and help solve mysteries that had puzzled scientists for decades. At first glance, the sun may seem well understood. It powers life on Earth, drives our climate, and sits at the center of our solar system. Yet one of the biggest mysteries in astrophysics involves a basic question. Why is the sun's outer atmosphere hotter than its surface? The visible surface of the sun, called the photosphere, has a temperature of around 5,500 degrees Celsius. Logically, temperatures should decrease as you move farther away from the heat source. However, scientists discovered that the sun's outer atmosphere, known as the corona, reaches temperatures of more than 1 million degrees Celsius. This finding completely defied expectations. Imagine standing near a campfire and discovering that the air several meters away is hundreds of times hotter than the flames themselves. That's essentially the puzzle scientists faced when studying the sun. Another mystery involved the solar wind. The sun continuously releases billions of tons of charged particles into space. These particles travel at incredible speeds and influence every planet in the solar system. Scientists understood that the solar wind existed, but they didn't fully understand how it was accelerated to such high speeds. These questions were more than academic puzzles. Solar activity can disrupt satellites, interfere with GPS systems, damage power grids, and pose serious risks to astronauts. Understanding how the sun works is essential for predicting and preparing for space weather events that affect modern technology. To solve these mysteries, scientists needed data collected directly from the sun's atmosphere. Sending a spacecraft close to the sun presented enormous engineering challenges. The biggest obstacle was heat. Near the sun, temperatures can reach levels that would instantly destroy conventional spacecraft materials. Electronics would fail, instruments would melt, and solar panels could become unusable. NASA's solution was the Parker Solar Probe, a spacecraft specifically designed for one of the most extreme missions ever attempted. At the heart of the spacecraft is a revolutionary heat shield made from carbon composite materials. This shield is approximately 11.5 centimeters thick and protects the spacecraft from temperatures approaching 1,400 degrees Celsius. Remarkably, while the front of the heat shield experiences extreme heat, the instruments behind it remain close to room temperature. This allows the spacecraft's sensitive electronics to continue operating normally. Getting close to the sun also required a unique flight path. Instead of traveling directly toward the sun, Parker's solar probe used multiple flybys of Venus. Each encounter with Venus acted like a gravitational slingshot, gradually shrinking the spacecraft's orbit and bringing it closer to the sun with every pass. As the spacecraft moved deeper into the sun's gravitational field, it accelerated to unprecedented speeds. Eventually, it became the fastest human-made object ever created, traveling at hundreds of thousands of miles per hour. Every aspect of the mission pushed the limits of engineering, navigation, and material science. Yet all of these innovations served one purpose: allowing humanity to explore a region of space that had never been visited before. In December 2021, Parker Solar Probe achieved something historic. It became the first spacecraft to enter the sun's atmosphere. Of course, the sun doesn't have a solid surface that a spacecraft can land on. When scientists say Parker touched the sun, They mean it crossed a boundary known as the Alfvén critical surface. This region marks the point where the sun's atmosphere ends and the solar wind begins its journey through space. For decades, scientists could only estimate where this boundary existed. Parker's solar probe changed that by crossing it directly and collecting measurements from inside the corona itself. As the spacecraft moved through this region, its instruments recorded magnetic fields, charged particles, and plasma conditions unlike anything previously observed. Scientists suddenly had access to information gathered from inside the sun's atmosphere rather than from far away. The crossing represented a major milestone in space exploration. It was comparable to the first moon landing or the first spacecraft entering interstellar space. For the first time, humanity was directly sampling material from a star's atmosphere. More importantly, this achievement opened the door to discoveries that scientists had been seeking for generations. The data collected during these crossings would reveal unexpected structures, strange magnetic behavior, and new clues about how the sun operates. Entering the sun's atmosphere was a historic achievement on its own, but the real purpose of the mission was to collect data. Scientists expected Parker's solar probe to answer a few long-standing questions. What they didn't expect was for it to uncover entirely new mysteries. One of the most surprising discoveries involved strange magnetic structures known as switchbacks. As Parker traveled through the solar wind, its instruments detected sudden reversals in the sun's magnetic field. Instead of flowing smoothly outward, the magnetic field appeared to bend and twist back on itself. Scientists had observed hints of these structures before, but nobody expected them to be so common or so powerful. Some switchbacks were large enough to significantly alter the flow of charged particles moving away from the sun. Researchers now believe these magnetic disturbances may play an important role in accelerating the solar wind. Another major discovery involved the structure of the corona itself. Before the mission, many scientists imagined the sun's atmosphere as a relatively smooth region. Parker revealed something completely different. The corona turned out to be highly dynamic, filled with complex magnetic structures, plasma streams, and constantly changing activity. The spacecraft also observed evidence of magnetic reconnection. This process occurs when magnetic field lines break apart and reconnect, releasing enormous amounts of energy. Magnetic reconnection is believed to power solar flares and contribute to heating the corona. Parker's observations provided some of the clearest evidence yet that these events occur frequently throughout the sun's atmosphere. Perhaps most importantly, the mission brought scientists closer to solving the mystery of coronal heating. While the puzzle has not been fully solved, Parker's measurements suggest that waves traveling through the sun's magnetic field and frequent magnetic reconnection events may be transferring energy into the corona, causing it to become far hotter than the solar surface below. Each discovery revealed that the sun is far more complex than scientists previously imagined. Instead of answering every question, Parker opened the door to an entirely new generation of solar research. If you found this video helpful and enjoyed learning about NASA's incredible mission to the sun, make sure to subscribe to SciTechSignal for more fascinating science, space, and technology videos. Don't forget to like the video, leave a comment with your thoughts, and turn on notifications so you never miss an update. Thanks for watching, and we'll see you in the next video.